All right, so we have pre-processed our text. I'm going to squeeze this up to tighten things up just a little bit, but so we can still read everything. So we've pre-processed our text. One of the next things we may want to do is, well, let's just see what kind of words we have in this text. So if we go back to our text analytics, the very first item we see in here is called convert word to vector. So what this is going to do is it's going to create a list of words that we have, and then we can actually create a set of dimensions. So this is called the word embedding, length of word embedding. And these dimensions basically are defined in such a way that each word belongs to each dimension to a certain degree, okay? And we can describe which strategy we want to use, which training algorithm we want to use. We'll go with the defaults here. Again, we can always go to the component information and see more about the pill. And one thing to note about the strategy is that this glove one up at the top actually has a pre-trained model of the English language in it. Length of word embedding, basically we're providing 100 columns or 100 dimensions. We have a pretty small document set here, 1,200 or so documents, so that might be overkill, but that's the default. We can leave it as it is. Let's take a look at this context window and number of epochs. So number of epochs is basically how many iterations are we going to go through. The context window is a spacing or a distance function. What's the maximum distance between the prediction and the actual word that we want to allow? And then also we can say, what's the maximum number of words in the vocabulary? It defaults to 10,000. We can adjust that up or down. Again, with 1,200 documents, I doubt that we'll pass that up, but we'll find out. And then the minimum count of one word. So this is the threshold that we want to use to actually include the word in our dictionary. And 5, since we have a pretty small number of documents, may be a little bit higher than we want, so I'm going to make that 3. And we can run it and see how things look. Oh, I do have to select a column. Now, one thing to keep in mind is we've pre-processed the text. So here's what I've run in the past. If we look and see what the resulting fields are, columns, we've got 10. But look at the new names of the columns. We've got pre-processed responsibilities, pre-processed minimum qualifications, pre-processed preferred qualifications. So we want to use those rather than the original columns, responsibilities, minimum qualifications, preferred qualifications. We could actually put a select columns in to kind of help make sure we don't use one of the original columns by mistake. But I'm going to hold off on that, and we'll do that a little bit later because once we've processed our text, we want to get rid of the original text before we move into any prediction algorithms. All right, so let's go back to our convert word to, and of course I forgot which one we're going to work with. So one thing to keep in mind is some of these will allow you to feed in multiple columns. Others require a single column. So convert word to vectors is a single column pill. So the one we want to use, I would probably, if I had to choose just one, I would use the preferred qualifications. So let's take a look at that one again. So pre-processed preferred qualifications. I'll bring that one in. Save it. And let's run it and see what we get. I'll pause the video and come back when it's finished. Okay, so we're done. And when we take a look at the output here, you can see we have one output called vocabulary with embeddings. So we take a look at that. I can expand that. And you can see it ended up giving me 1,527 distinct words. So yeah, well below that 10,000 we had as a max, and 101 columns. So my original vocabulary, or my vocabulary word itself, and then these 100 embedding dimensions that we can then see, okay, context has a positive value for dimension 0, a minor negative value for dimension 1, and a higher positive value for dimension 2, and so on down the line. So we would then be able to run some of our distance algorithms, distance-related algorithms, or any algorithm for that matter, but distance-related unsupervised algorithms such as clustering, to see if we could figure out which words appear near each other, and we could use that to help guide our efforts. One other thing that happens when we build a dictionary like this is we have the ability now to see, okay, what words do we have? So I may see statistics and analysis here. I may see another word later on, analytics, and say, well, based on the project I'm working on, those would be similar enough that I would want to count those together, which means that I would then go back to my process text, or maybe even add a new process text, and go down here and add a customer regular expression. So I would maybe say, let's make statistics and call that analytics. So this is a process, as you can imagine, that is actually fairly intensive, analysis intensive by the data scientist, and is one reason that text analytics, we've got a lot of automated tools, but they are not perfect yet. So a lot of work like this still needs to be done in a full-blown text analytics process. Now, you can imagine how many of these custom expression replacements we would have to add. So that would be, a new pre-processed text for each time we run across one that we want to replace. So there are a number of other tools that are available that actually streamline this process quite a bit. One is called JUMP, JMP. That's available from the SAS Institute. SAS is a huge statistical and analytical software company based in Cary, North Carolina. All right, so anyway, that's convert word to vector. We can do what we need to with this. Let's get back to the reading and see what we'd like to do next.